Okay, so in this question, we're told that we have an empty seal vessel, and it's charged with 0.2 atmospheres of C and 0.2 atmospheres of A. Now, notice right away that these are underlined because the numbers you're given in your problem will probably be different than 0.2. This is one of those problems that has variable data for you to work with. And it says, once the system reaches equilibrium, according to the reaction below, what is the equilibrium partial pressure of C? And we're given the equilibrium constant, in case of P, it is 11.2. And here is the reaction that occurs. Okay, so this is a rice table problem. And the way you know that is because you're given some initial amounts, and you're asked about the equilibrium amount, and you're given an equilibrium constant. So that's your clue that you should set up a rice table. So we have rows of R for reaction, I for your initial amounts, C for the change in amount, and then E for the equilibrium amounts. So those are our rows. And we want to make a column for each one of the compounds involved in this reaction. So we have a column for A, okay, and that reacts to form B plus C. So we'll just make columns for each one of those. And we're told what the initial amounts are. For C, it's 0.2 atmospheres, and for A, it's 0.2 atmospheres. And nothing is said about B, and so because of that, you can just put 0 in. Now, the next thing that we need to decide is in which direction is this reaction going to go, because it's not at equilibrium. These are not equilibrium concentrations. These are initial concentrations. So one important and helpful thing to do is to go ahead and write the expression for the equilibrium constant. Well, it's based on a reaction. It's products over reactants. We include gases and solutions. We don't include solids and pure liquids. Everything's a gas in this one, so we'll include partial pressure of B. That's going to be multiplied by the partial pressure of C, and divide that by the partial pressure of A. Okay, now we know that we can also use this expression to do a calculation of Q, that reaction quotient. And so the partial pressure of C, 0.2, times the partial pressure of B, 0, is going to be 0. So right off the bat, in this initial situation, we know that Q equals 0, which is less than 11.2. It's less than that equilibrium constant. So what does that tell us? It tells us that the reaction goes in the forward direction. The reaction goes forward. Okay, it's going to go that way. And that makes sense because we don't have any B, and nature wants there to be some of B. So we're going to produce X amount of B. And every time I produce a B, I also have to produce a C, so I'm going to gain X amount of C. And every time I produce a B and a C, I lose an A, so I'm going to lose X amount of A. All right, now what we do for the row of the equilibrium amounts, we just add up the columns. So this would be 0.200 minus X. This would just be X, and this would be 0.200 plus X. Now, what I can do is I can substitute these into my expression for the equilibrium constant, so I'll go ahead and do that. So the partial pressure of B is just X. Partial pressure of C is 0.2 plus X. Partial pressure of A is 0.2 minus X. And all of that is equal to what I know to be the equilibrium constant, 11.2. Okay. So, picking up from there, what we have to do at this point is we need to plug this into our calculator. It's a quadratic equation, so you have a couple options. You could just use the quadratic equation, expand it out, figure out what A and B and C are, and then solve it that way. But it's much, much nicer if you have a calculator that will solve equations for you. So I'm going to show you how to do it with the TI-36X Pro, so I'll show you how to do this. But what I did to get to this screen was I did second and then number solve, okay, to get to this screen. And as you can see, it's an equivalency. It's blank equals blank, so we just fill in the blanks. So on this side, I push this button to get a fraction, and I'm going to make the fraction just look like what I have in my problem statement. So I'm going to go parentheses, and then the button you push for an unknown to get an X in there is this one right here. You can't see what I'm pushing. It's that one right there. So I push that to get an X in there. I close the parentheses, and then I'll open up another set of parentheses, and I go 0.200, and then plus, and then there's that X again, and then close those parentheses, and go down, cursor down. So then I do a parentheses, 0.200 minus X, close parentheses, and then I cursor over to the other side of the equal sign, and I put in 11.2. Oops, nope, delete that. 11.2. Okay, so now when I hit enter, one thing you got to make sure you do with this calculator is if you have a number in this X spot, you got to change that to 0. So I'm going to just put in a 0, and you cursor down to solve X, push enter, and there's a little hourglass that tells you that it's thinking. When it's done thinking, it gives you the answer, okay? So it solved that equation for you. It solved for X, so X is equal to, in this case, 0.193. All right? Now, we haven't really answered the question yet because the question says, what is the, go back to the question here, what is the equilibrium partial pressure of C? Well, that is 0.200 plus X. So the answer is going to be 0.200 plus 0.193. and that equals 0.393 atmospheres.